Hi everyone. From this video I am going to explain chapter 3 of module 3. The chapter name is error detection and correction. Now we will discuss what is meant by error detection and correction. The topic is introduction to error detection and correction. Okay, what is meant by an error? When a bit flow from one point to another point, they are subjected to unpredictable change of interference. Means the bit may be changed. For example, if sender is sending 1 means while receiving it may be changed to 1. This is unpredictable change of interference. The change in the bit, it is resulting in the change of the shape of the signal. Means if the unpredictable change in bit means it resulting in the change the shape of the signal. There are two types of error. One is single bit error. Next one is burst error. What is meant by single bit error? Only one bit of given data is changed from 1 to 0 or 0 to 1. Okay, in this diagram you can see that these are the bit 0 0 0 0 0 1 0, but here while this is sender data, this is receiver data, but you can see thus here 0 is changed to 1, means corrupted bit. Means here only one bit is corrupted, means it is changed from 0 to 1. This should not be happen. Okay, so here 0 is changed to 1 means this is corrupted bit. Okay, next one is burst error. Means nothing but here 2 or more bit in the data have changed. Here only one bit is changed. Here 2 or more bit change from 1 to 0 or 0 to 1. You can change the, you can see that this is send data, this is received data. Here you can see that this is length of the burst error, 8 bit. Here to here you can see that here 1 is changed to 0, 0 is changed to 1, here 0 is changed to 1, here also 1 changed to 0. These are corrupted bit. Here only one bit is corrupted, here more bits are corrupted. Why this burst error will happen? Because normally duration of the noise is larger than duration of one bit. Means suppose this is one bit, 1 year to year, the duration of noise is larger than duration of one bit, means the noise duration is greater than the duration of one bit. So the burst error will occur. When noise affect the data, it also affect the bit. Means data is nothing but it is a collection of bit. If data is affected by the noise, means then bits also it will be affected by noise only. Okay, this number of corrupted bit depends on data rate or bit rate. What is meant by bit rate or data rate? Nothing but number of bit per second and duration of the noise. The corrupted bits is depend upon, number of corrected bits depend upon data rate or bit rate and duration of the noise. Next one is redundancy. What is meant by redundancy? Central concept in detecting and correcting error called as redundancy. Redundancy is nothing but central concept in detecting or correcting error called as redundancy. Okay. Next, what is meant by redundancy? Bit. Some extra bit along with data have to be sent to detect or correct error. It is called as that extra bits called as redundant bit. Suppose this is data to be detected. This is data sent to correct or detect the error. Here I am going to add some more bit along this data 1 1. This 1 1 is called as redundancy bit. That only they are telling some extra bit. These two are extra bit along with data have to be sent to detect a correct error. You can see that this is the data. I am adding extra 2 bit. This 2 bit will called as extra bit. Extra bit is called as redundant bit. Redundant bit are added by the sender. This redundant bit are added by the sender and removed by the receiver. This extra bit is added by sender. This extra bit, nothing but redundant bit, is removed by receiver. Okay. Next, presence of redundant bit allows the receiver to detect a correct error. If redundant bit is present with the data, means it allows the receiver to detect a correct error. Why you are using this redundant bit? Means to receiver to detect a correct error. If the redundant bit is present in the data, means the receiver have to detect or correct the error. Next one is error detection versus error correction. Here error correction is more difficult than the error detection. Means error detection is easy, means error finding is easy, but error correction is more difficult. Okay, what is meant by error detection or error finding? We are checking the whether any error has occurred or not. Okay, means any bit is corrected or not, you are checking here. Means you are checking the whether any error are occurred or not. Means error means the bit is corrupted or not, you are checking here. You are not interested in the number of corrupted bit. What we will do in error detection means you are going to check the bits are corrupted or not. If it is corrupted, we are not going to check how many number of bits is corrected. Means we are not going to give the importance to how many bits are corrupted. We are seeing the data is corrupted or not. That is important. Not how many bits are corrupted. It is not important in error detection. In error correction, here we need to know exact number of corrected bits. Here we are not going to give the importance to how many bits are corrupted, but in error detection, exact number of corrected bit and location of bit in the message. Means we are going to give the importance how many bits are corrupted and where the bits are corrupted in the message. We give the importance here. And two important factors to be considered: number of errors and message size. Okay. 1 second, I am telling. Here error correction is more difficult than error detection. Okay, next, what is meant by error detection? You are going to find corrupted bit here, and we are not going to give the importance how many bits are corrupted, but in this error correction we are going to give the importance how many exact number of bits is corrupted and where the bits are corrupted in the message we are going to find here. And two factors are important: number of errors and message size. Next one is coding. What is meant by coding? Redundancy is achieved to various coding scheme. To achieve this redundancy, have various coding schemes. Okay, what are the various coding scheme? We'll see here. Okay, sender adds redundancy bit. This process create a relationship between redundancy bit and data bit. Means if sender will add the bit for the if sender adds redundant bit to the data, this process creates the relationship between the redundant bits and data bit. Receiver checks the relationship between the redundant bit and data bit to to detect or correct the error. Here in the sender side, the sender will add the redundant bit for the data. This process creates a relationship between redundant bit and data bit. Okay, in receiver side, the receiver checks the relationship between the redundant bit and data bit to detect or correct the error. In coding, two factors are very important. What are the two factors? Ratio of redundant bit to data bit. Means we are going to consider ratio between redundant bit and data bit, and robusting of the process. These are the two important factors for the coding. There are two types of coding scheme, nothing but black coding and convolution coding. There are two coding scheme. First one is black coding, next one is convolution coding. In next video I am going to explain the black coding. Okay, what are the topics we discussed today? What is mean by introduction to error detection and correction. Here there are two types of error. One is single bit error. Single bit error means only one bit changed from 1 to 0 or 0 to 1. In burst error, there are two or more bits are corrupted. Okay, the number of corrupted bits depend on data rate and duration of the noise. What is mean by redundancy and what is mean by redundancy bit? Then what is mean by error detection and error correction? And coding, there are two types of coding: black coding and convolution coding. In next video I am going to explain black coding. What is mean by black coding, how we can do color error detection and correction. Okay, thank you.